Students, what can be the nature of the electrostatic potential? So electrostatic potential is a scalar quantity. It has no direction. So whenever we apply superposition principle to get the value of electrostatic potential in the presence of many charges in the space, in that condition we need to take algebraic sum of the individual potentials. So that is why electrostatic potential is a scalar quantity. Remember this. Student, this is graphical variation of the electrostatic potential. So in the previous expression we have seen electrostatic potential due to a point charge is directly proportional to magnitude of the charge q, and it is inversely proportional to distance of the point where electrostatic potential is determined. Here in this graph you can see if we plot electrostatic potential and electric field together with respect to distance r from the source charge. Here you can see two graphs are there. Black line, that is for electrostatic potential. Here you can see the rate of decrease of the potential is less as V is proportional to 1 by R, but rate of decrease of the electric field is a rapid rate as compared to the potential for the same distance. If we plot graph for both the quantities on the same scale, we are going to get difference like this. But if the charge is negative, in that condition the potential is going to be in negative direction. Here you can see this would be the shape of the graph, distance from the source charge and potential. Students, if we plot a graph between electrostatic potential due to a point charge versus 1 by R, the graph is going to be a linear graph. For any charge greater than 0, it means the given charge is positive charge, the graph is going to be a positive quadrant. If a charge is less than 0, that is the charge is negative, the same graph V versus 1 by R is negative, and it's a rectilinear variation. Students, see, this is a question related to graph of the electrostatic potential versus distance 1 by R. In this question, figure shows variation of electric potential V with respect to 1 by R, where R is the distance from the two charges Q1 and Q2. Determine number 1, sign of the two charges Q1 and Q2. Sign means their nature. You have to decide what is the nature of charge Q1 and nature of charge Q2. In the second part of the question, which of the two charges has larger magnitude, and justify your answer. Students, in this question, potential in this region is negative and potential in this quadrant, this is first quadrant, is positive. So for a positive charge, potential in the nearby space is positive. For a negative charge, potential is negative. So first part of the question, sign of charge Q1 is a positive and charge Q2 is a negative charge. Just looking this graph, we can decide the nature of the charge whose graph V versus 1 by R is given in the question. Now second part of the question, which of the two charges has larger magnitude? For any value of R, if we determine value of the potential due to that particular charge, you can see for the same value of 1 by R, potential of charge Q1 is less than potential of charge Q2. So which of the two charges has larger magnitude? So answer of the second question, potential of charge Q2 is greater than potential of charge q1 for the same distance r. That is why magnitude of charge q2 is greater than magnitude of charge q1, as r is, or 1 by r is remaining constant. So electric potential due to a group of point charges, or electric potential due to a system of charges. So electric potential due to a group of point charges. Suppose charges q1, q2, q3, q4 up to qn are in a nearby space to point P. Their distances are r1, r2, r3 and rn. So what can be the total value of electric potential at point P? So total potential at point P is going to be algebraic sum of the individual potentials. So if potential due to the presence of these charges at point P are written as V1 equals k q1 by r1, V2 equals k q2 by r2 and so on, Vn is equal to k qn divided by rn. Then what is the total potential at point P? Can be written as k summation I from 1 to n qi divided by ri. This would be the expression. But students, remember one thing, this sum is algebraic sum. Algebraic sum means these potentials are not having any direct sum, but whenever we are going to do the sum, we have to take the sign of the charge into consideration. If many charges are negative in the group, the potential at point P is going to be negative, as well as potential at point P in the presence of positive charges is going to be positive.